Good morning. Welcome to the Droidcon Italy webinar. My name is Lucy James. I'm one of the Droidcon Italy organisers. Today's webinar is brought to you by Synesthesia and it is sponsored by Bluetooth. And we have with us today Ash Davies. Ash, how are you today?
I'm good, thank you. And yourself?
Yeah, I'm good, thank you. How are things in Berlin?
A little bit overcast still. And I think we're starting to see signs of autumn. So yeah, summer is finished.
To be expected. Ash, you're going to be talking to us today about Dagger and Kotlin.
Mm-hmm.
Yeah. So thank you very much for being with us. Thank you for preparing your webinar.
No problem.
We'll see you at the end for Q&A. In the meantime, any questions can be posted in the comments bar of YouTube. Ash, have a great webinar.
Thanks. So, hi everybody. I'm Ash Davies, and I'm working for Immobilien Scout in Berlin. So today I'm going to be talking about working with Dagger and Kotlin. Now this presentation has gone through a few iterations. I've done my best to keep it up to date, but there might be some things I've missed. Please send me a message if that's the case. But I'm also going to go through the history of Dagger and how we've used it with Kotlin, some problems we've had, and how some of those problems have been solved and how they will continue to be solved in the future. So let's start off with what is DI, what is dependency injection? We use it often in our apps and it becomes sort of second nature. We don't often think about how this is implemented. It's just a status quo matter of fact. So let's take our favorite example, a thermosiphon that hits a pump. That is in a different example. So, sorry, excuse me. So let's take a car that has an engine, and we want to create a new instance of this car and then start it. Now, in the class definition for car here, we can see that it's actually creating its own engine. So this is obviously quite difficult to test because we can't replace the engine if we wanted to. So if we adjust that to take the engine as a dependency through the constructor, we can then provide it with a different engine at runtime, perhaps one that is more suitable for testing. You could provide some mock responses or some stub information. So a lot of people, when they see all these Dagger talks and presentations about how to make Dagger simple, and it seems a lot of overwhelming information, and a lot of people, quite understandably, then will just react by saying, well, I'm just going to use something else. Coin looks quite attractive, or manual dependency injection looks easy. I'll just avoid Dagger until I absolutely have to do so. And that's fine if it works for your projects. But it also sort of started these conversations about which one is the better dependency injection framework, Dagger or Coin. And if you look at the comment of this Reddit thread, you'll notice that it's from the head of sales at Bob's Discount Action Bars, which led to a very heated discussion about how Coin is not dependency injection. So we have to understand that there's a difference between service location and dependency injection. Service location is more retrieval, and dependency injection is more provision. There is still the difficulty of having the dependency injection target knowing how to retrieve its dependencies, which it shouldn't, as per all best practice guidelines. So a service locator might look like this. We have an object that contains the dependency we want to retrieve, and then when instantiating the car, it retrieves the engine from the service locator. This works fine for small projects, but it doesn't scale very well. Actually, one approach I use for my own personal projects is combining top-level functions with, top-level variables with default parameters. This way, you can still use dependency injection when you're testing the individual class, but also get very easy to set up service location. But again, this isn't going to scale very well because you can't scope out dependencies, you can't adjust modules, you can't provide a full navigation graph, destination graph. It's just for getting things going. So what is Dagger 2? Dagger 2 is a opinionated dependency injection implementation of the JSR 330 notation for Java. It generates code for the injection and uses compile time safety. So it doesn't have any reflection, whereas its previous iterations did. The important thing to notice about Dagger, or important thing to remember about Dagger, is that it's written in Java, for Java, by Java, with Java software engineers. The point there is that it's an annotation processor-based dependency injection framework. So the code that your annotation processor is going to see is Java code. It's a Java annotation processor. So it's not going to see a lot of the Kotlin information only through Kotlin metadata. So this is one of the fundamental concepts that allows Dagger to kind of operate as it does, and that is code generation. And it's important to understand what code generation is, and it's based upon annotation processing. So you might annotate a class, and that gives you some information about that class, and then you would, using a annotation processor, generate new code as a result of that annotation. You are not able to modify existing code, only generate new code. So obviously that poses various problems when you're trying to couple that with production implementations. Some other good examples of code generation might be using auto value. This is before we had data classes in Kotlin, where we would have Google auto value to generate a data class representation of a Java interface or abstract class. But then you would still have to couple that at runtime by using a create method. And then there would be Lombok. Lombok is a bit different from annotation processes, where it actually modifies the existing bytecode. It does a lot of crazy things, and it's extremely powerful. Personally, I would probably say it's voodoo, stay away. But if you are brave, there's definitely some benefits to be had. And then finally, we have Dagger, which is able to generate binding expressions for dependency injection. Now, there's a great talk from Jake Wharton, and the slides aren't moving. There we go. There's a great talk from Jake Wharton about helping Dagger help you, where he talks about using Dagger best practices in your applications, not just particularly towards Kotlin, but towards getting started with a project and using it to the best of your advantage. I'm going to cover a couple of techniques in this one, particularly how to use view inflation. But the point of this talk was that the code generation is going to be the same as the code you write yourself, and it helps us generate reliable code for dependency injection. And if you start off with a good foundation, then you can have a very easily scalable project. So a bit of history about Dagger. It's not exactly the new kid on the block. It's been around for a few iterations and has a long history. Originally built on Juice, pronounced like the drink, Juice, developed by Google, around for a very long time, and actually still under active development. Then Square built Dagger with influences from Juice, but not extending from it, and builds upon the JSR 330 JavaX.inject annotations for Java. It significantly reduces the amount of runtime reflection necessary, though it doesn't eliminate it. And then a little bit later, Google took it back over to completely remove reflection and rely upon code generation instead, which has been basically a representation of dependency injection, but for Android or for high constraint devices. So Kotlin, created in 2011, was Project Kotlin, first stable release in 2014. Recently adopted by Google as a primary language for Android development. It's fantastic. We all love it, and we want to learn more about it. That's why we're all here. So, working with Dagger and Kotlin, I often think of it as a love-hate story, but there are moments. So Dagger can work with Kotlin, but it's working with the generated Java, and it relies heavily upon the Kotlin interoperability to function properly. And a lot of these things are built upon annotations. Being an annotation processor, you have to be very considerate about your annotations and how they all affect your code in Java when using them in Kotlin. So for a start, there's the java.lang.annotation. This is a retained annotation that we specify for our other annotations to specify how it should be retained, whether it should be as part of a binary available at runtime, or if it's just for documentation purposes. Of course, Dagger is going to need it for runtime reflection. Earlier versions of Dagger need it for runtime reflection, but this is also the same or for compile time. So you want to make sure that you're using the Kotlin version of the runtime annotation instead of the Java one. This will actually be flagged in your IDE as a lint error, but I think it will still actually allow it to compile. The qualifier is actually part of the JavaX inject library, so you don't have to use a different version of this one, but you do have to make sure that you're still passing this for qualifier injections and when using the retained annotation as well. Again, scope is quite important as well, and this has further things coming into play in a minute when I'll explain about targets. But these are the annotations we need to consider. Finally, singleton, which is a type of scope, or it's a scope annotated annotation, which will apply to a dependency to ensure that it has one provision for the entire scope of that component. A small tangent here, singleton annotation is not the same as the singleton pattern. This is achieved in Kotlin using the objects class, objects thing, which then ends up using double check locking. Now, this is actually quite expensive as a algorithm because it then has a synchronized block with a null check before and after, just to make sure that you're resulting in the right version of your dependency. You can compare this to the Kotlin Lazy instantiation, where you're using different types of thread safety modes. If you're using Lazy in Android, most of the time you're only going to be using an unsafe Lazy implementation because we're in a single-threaded environment and we don't have to worry about threading. So it's safe in most cases for Android to actually disable this. But be aware that when you use scope, you will be using this double check. And if you want to have something that maybe can just be reused, we have the reusable annotation, which uses a single check algorithm, which is a bit lighter and just basically says reuse this if you can, no worries if you can't. It's great for expensive dependencies, works great in single thread environments like Android, and you're not guaranteed to have the same instance in multiple threads. It's very rare that you'll have a different version, but it still can happen. And it's better overall to keep your Dagger graphs stateless. So try and keep components and modules without having anything you have to instantiate them with. Cool. Also, a final note, try not to annotate your implementations with your scope because this, whilst the Dagger documentation does actually specify this as a documentation for the implementation or for the developer, I feel, and many others feel, that it's confusing the how with the why. So the implementation shouldn't be concerned about how it's used in its scope, and it shouldn't behave differently because of the scope. It should be down to the usage declaration, so your binding expression or your provides expressions, to say how this dependency is scoped, because you can end up with unexpected behavior due to incorrectly perceived or retained state. And it can be tricky to debug because you don't know why this is actually being persisted. So keep persistence in the target injection site target. So looping back as to why these annotations are actually important to consider, consider construction injection, where you have the named annotation. This is to differentiate from a type of a similar, from a dependency of the same type. In the generated bytecode for this, you'll end up with something like this, where the constructor is annotated with injected, and the annotation is applied to the parameters appropriately. So here, Kotlin and Dagger both know, looking at the JVM code, what annotations mean, where the significance is, and what to do in reaction to this. Now compare this to field injection. This is not so inherent. It's not clear what these annotations should be applied to, because in our constructor, please ignore the erroneous declaration here with the parentheses, but it's not clear which the annotation should be applied to. Should it be applied to the member variable, or should it be applied to the constructor parameter, or should it be applied to the getter or some intrinsics somewhere else? So as a result, it's going to be in the wrong place. So you might ask, why are we using field injection when constructor injection is much more clear because, field injection, you have mutable properties, the annotation target is unclear, it's difficult to configure and test, you don't know which one of the dependencies have been mocked or set up. Where compared to constructor injection, you have immutable dependencies, they're easy to use, it's reliable injection, so you can be sure that if you're using all of the dependencies in the constructor, that you are correctly configuring and setting up this application, this test ready for use. And obviously, you're going to get compilation safety rather than runtime potential runtime failure. And the reason why we do this is because of our little green friend. Now, we have several manifest elements in Android that we don't have full control over. For example, the application, activity, broadcast receiver, class loader, content provider, and services. The reason for this is that if for some reason our configuration changes, the user rotates the device, shows the keyboard, shows a second screen now that we have multi-screen devices. However, whatever reason the device might have for changing the configuration, our entire world is destroyed and recreated. So in this case, your activity might be destroyed and recreated with saved instance state bundles, or your fragments might be persisted, or for whatever reason, your component is destroyed and recreated. We don't have control over the recreation of that, and we have to serialize and encode our state into something that can be persisted through orientation change, configuration change, sorry. So in Android 9, it's API version 28, or Android Pie, the last version of Android to be named after a tasty delight. We are given the app component factory, which we can specify in our manifest, which actually provides us with the potential for creating these or having a factory for these individual components: application, activity, class loader, service, receiver, provider. And now this means that each one of these components will be able to use constructor injection. And then we'll then use the factory. So you can then use a similar approach to the viewModel factory or the save state instance factory with Dagger that I'm going to go into in a bit, to dependency inject your components here, which is quite cool. The downside to this is, of course, we're all not as lucky to target API version 28 as a minimum SDK version, and it currently only sits around 30% as of April 2020. So it's not really feasible for us all to start targeting this. However, there is a representation in the Android X compat library, so you might be able to start making use of it safely, but there will be no shims for it. If you're making use of the single activity architecture with the Jetpack navigation library, you can already start making use of the fragment factory, since this is part of Android X, not a framework dependency. So you could actually use this technique to inject dependencies into fragment constructors. This also applies to abstract save state VM factory, but more on VMs later. There's also a technique that Jake covered in his Helping Dagger Help You talk, using layout inflator factories with assisted inject. Now, this actually allows us to inject dependencies into a view, something which was not really feasible before because we weren't really sure where to retrieve context from, because a view could be attached to very many different things, and should it get the Android injector from the fragment, or should it get from the activity or from the application? Here it's a bit more straightforward because these attributes are provided at runtime. You're only providing the additional dependencies as necessary. So the factory actually needs to be instantiated with the image loader, and then at runtime it'll be provided with the context that it would normally be provided with when injecting when inflating a view. So using a image loader view like this, you'd need to use an application layout inflator factory like this, which has the factory provided, and then you can start using this in your dependencies. There have been very other different approaches to using this, and similar approaches using data binding, but this is quite useful and lean, but it is also prone to abuse, so be very apprehensive in your usage of it and careful, and be sensible. So back to field inflation. Field injection, sorry, later init var. So we have our named annotation on these players. We saw earlier that this would result in, sorry, no, we didn't see it. This actually results in not knowing where the annotation should be placed. In this circumstance, it's not actually placed on the member field, nor is it placed on the getter or setter, but it's placed in this synthetic annotations method, which Dagger doesn't really know to look for, or didn't really know to look for. So this would actually fail at compile time because it wouldn't know which dependency to actually inject, and you'd have to then specify manually. You do so with the field annotation. This then says, this annotation needs to be applied to the field in the JVM representation, which is fine. This works. And we have the same thing for set, get, param, property, set param, receiver, and delegate. Now, this obviously started kind of the discussion in October 2017, where Ron Shapiro opened the topic to discuss Kotlin and Dagger pain points, documentation, best practices, and this is sort of where discussions for this started to begin. I very much recommend checking out this thread. I'll share the slides at the end as well so you can see it. But some of these important revelations have been, as of Dagger 2.252, released October 2019, qualifier annotations on fields can now be understood without the need for the field specification. So the synthetic method I showed you just a few slides ago, Dagger is now clever enough to read from this, and you don't have to worry about having the field annotation on your inject or fields annotated injections. Furthermore, module objects no longer need to have JVM static on their provides method. I'll go into a bit more detail about why this is significant in a second. And then later on with Dagger 2.2.8, June 2020, introduces a lot of lint checks to cover these previous use cases. So if you still have your fields site targets in your injected properties, these will be highlighted as lint errors or lint warnings, sorry. Again, with using redundant JVM static and object modules and annotating companion objects with @module. These are no longer necessary, and the lint rules will highlight them so you can clean up your code effectively. So moving on to modules, what do they look like in Kotlin, and what is the best practice for declaring them in light of the facts of the recent Dagger implementations? So there's a nice FAQ entry in the Dagger documentation stating, well, why can't binds and instant provides methods go in the same module? And in abstract, they used to. In Java, they used to, because we'd be able to have this static keyword, which doesn't really exist in the same way in Kotlin. To achieve the same thing in Kotlin, we would have to make use of a companion object, which might look something like this, where you have the abstract function or the interface function at the top level of the module, and then companion object with JVM static to make sure that this is generated properly in the outer module. You'd also have to annotate this module to make sure that Dagger recognizes it. But as mentioned in the changes to Dagger in Dagger 2.2.5 and 2, both the module annotation and the JVM static annotation are no longer required. Dagger is smart enough to find these for himself. So we only have to have the companion object with the provides. So a little bit nicer. Of course, the recommendation is to actually kind of try and split these up into different modules if you can. If you've got something that only uses binds and then something that only uses provides, it's a little bit easier to manage. But this is also fine to use. You can also use actually just stick with using Java objects, Java classes for Dagger modules. There's absolutely nothing wrong with that. But some people prefer to go all in or all out with Java and Kotlin. There are some, of course, performance benefits if you have a pure module with either Java or Kotlin. But if one module is your cause for concern, you probably have fewer problems than I do. So yeah, another thing to consider is inline method bodies. Now the thing with Kotlin is that it's able to infer the return type, and you'll often have your IDE set up so that this return type is made visible in your IDE. So you don't actually have to specify it explicitly. However, remember, this is not the code that Java is going to see. Java is going to see it when it's, Dagger is going to see, Dagger is going to see the Java code. So in the first example of game module, this will actually be recognized as player one, not game controller. So this will actually end up with an incorrect binding, which is going to have a problem at compile time. And you might be kind of trying to figure out, why is this not binding the correct type? It's got the type there. What's going on? It's generally good practice and nicely to your colleagues as well, because this is also true when reviewing code in anything else but an IDE, for example, GitHub, where types are not inferred. It's generally good practice to explicitly define your types on any sort of publicly exposed function, or any function at all, generally, because it makes it much clearer in anything other than IDE what you're actually returning. So now to move on to some really exciting computer boring stuff. Generics. These are always fun to talk about, and I must admit that it seems like every time I look up generics, I immediately forget everything I knew, and it's really hard to keep this stuff retained. So if you struggle with generics, you are not alone. I do, and everyone else I know still does too. So the problem with generics is the Java interoperability. Wildcard types are not available in Kotlin in the same way as they are in Java. They are in some sort of way, but Kotlin uses a declaration site variance instead of use case site variance, and uses type projections instead. So what does that mean? So I'm going to borrow the example from the Kotlin Lang website, where they explain using the Java collection. It's collection. Now here we have the interface collection, which extends iterable, and we have the function add all. And it takes a wildcard parameter, question mark extends e. And well, what is the purpose of this wildcard here? What purpose does it serve? And you could think that maybe you could just remove it and have collection e instead, and that would make sense. But then this would mean that generic types are invariant. But what does this mean? So say we have a list extending a list of objects. Now this isn't true. You can't actually do this because these things don't extend from each other, and this wouldn't compile. But what if it were to compile and Java were not to prohibit this? It would actually cause a class cast exception. Why is that? So let's create a list of strings. Pretty simple allocation here. Then we cast it to a list of objects. This wouldn't always be possible, but we're doing so for a contrived example. And we say objects.add one, because an int is also an object, so this would actually work. And then we say strings.get the first item, and we try and retrieve that. And well, we're going to get a class cast exception trying to cast it to an int or anything other than a string. Sorry, no, anything other than an int. So that's going to be the problem there. So this is why we say that when adding things, we need to have something that extends that base bound type, so that the upper bound is a type covariant. You can use a handy mnemonic to try and remember this, and that is basically, the invariant or outvariant position is dependent on where the type is being used. And this is also how Kotlin emulates declaration site. Emulates use site through declaration site, meaning that the types are generated only for parameters. So if you look on the first function here for boxing, it takes a value and it returns a list of that value. It doesn't use any wildcards here because the type is not going to be modified or changed. It's actually quite clear, and it's not going to be mutable in that respect. Whereas when you're passing in something as a parameter into a function that are returning a primitive, that's where the wildcards will be used, because we need to make sure that we're passing in something that extends a string rather than just a string, because it might not work and it's not actually allowed in Java. So where does this make sense? So where does this affect us? Consider this list adapter with injection inject constructor that we're writing in Kotlin, and then this is actually going to be represented by a set of strings with a wildcard, which is not actually what we really want. So you have a list module, and you're using multi-binding to provide into a set of strings. Now you think that looks fine and should work, right? But that's unfortunately not the case. So the binding that Dagger will end up generating will be a set of strings, as we fully expect, but the injection into list adapter will be set wildcard, like so, list of wildcard extend string. So that means that the build will fail because the bindings do not match, and we're going to be very confused and very upset. But fortunately, there's a recommended easy solve for this, and that is to use the JVM suppress wildcards annotation. Now, this is sort of a very simple way of saying to Kotlin STFU, I know what I'm doing, and it results in the correct or the expected representation being shown in JVM, and then Dagger being able to recognize it and inject the correct type at runtime. Some other things to keep in consideration with Kotlin and Dagger are default implementations. So, for example, you can have an interface with default implementation. This is relevant whether you use the JVM default or how compatibility flag to make sure that it's using the Java 8 functionality. This is not going to work. I'm very sorry. This is the same for default properties. This is also not really going to work, though there's more potential for this than there is for default implementations. Also same for JVM defaults, because this is going to result in every one of the generated constructors or methods having the annotation inject, which is fine if you have multiple traditional members, but if you have multiple inject constructors, Dagger's not going to know which one to use, and we'll have problems there. Same with inline classes. Inline classes are used for wrapping types that can introduce runtime overhead. Performance can be worse for these primitive types, and initialize the single bracketing property, and sometimes used with the backing field if necessary, if it can't be represented properly with the backing primitive field, and then sometimes represented as a box type. These are also not compatible because Dagger does not see the Kotlin code. It only recognizes the backing type, which is Java. Sometimes it might be the box type, but it's very unreliable, and you cannot rely upon that in Dagger. The provide annotation is not complex enough to require a wrapper, and inject site's not complex enough to require a wrapper. So it's going to cause problems because your backing type is going to conflict with maybe other backing types that you don't have if you're not using named annotations. This is the same for type alias, as these are represented through their underlying JVM type. Cool. So moving on. We have working with Dagger and Kotlin and Jetpack, the exciting new talk around the water cooler. Jetpack obviously was introduced not so recently in 2008, the IO Dev keynote, aimed at bootstrapping modern Android developments, opinionated implementations, breaking up support libraries, and migrating to the Android X namespace. One of the most important parts of this was the view model. This was because it was an opinionated style and approach for handling configuration change, because this had always been a headache for Android developers. So this was quite refreshing to have some guidance on how to actually achieve this. The downside to this, actually, however, is that because of its implementation of usage of non-configuration instances through headless fragments, it would require the activity to be fully created before your first view model can be created. So by necessity, it has to have some correlation with the activity. This doesn't mean that it has the same scope, because the view model scope extends that of the activity, but it does require the activity context in order to be created in the first place. So because of the view model scope extending the activity scope, it's really important that a view model must ever reference a view, lifecycle, or any class that may hold a reference to activity context. This is especially pertinent when it comes to live data, but we don't have to use live data. We've got stateful flow now. But let's consider a contrived example. So you have the game view model here, which doesn't have any dependencies, but it has an inject annotated constructor, and we inject the constructor into our activity. Looks fine, right? But unfortunately, this will work correctly. It will compile safely, but it will not work correctly. Since what's going to happen here is you'll end up with a fresh version of game view model on every configuration change. Not ideal, and you might wonder why your state is not being correctly persisted. So yeah, one does not simply inject a view model. You need to use the actual view model provider.factory that is available. So let's take our view model again. Now this is a common approach for handling view model injection. I'll go into Dagger view model inject soon, but I would like to establish the status quo in our current situation if you're not able to use hilt just yet. So you might have a game view model, and then you have a view model key, which allows you to use Dagger multi-binding, so you can bind the game view model into a map of view models. So the key would be the game view model class to the game view model constructor. And then you can use this with this nifty little view model factory. I'll show slides at the end. You can get some code if you'd like. Here we're actually injecting a provider a map of class to provider's view model, which means that given the class of view model, we can find the provider and create it at runtime using this provider to make sure that we're not unnecessarily creating a view model, creating the wrong view model, or making sure that we have the correct assignable keys available. Now, this will obviously fail at runtime if you do not set up your view model maps correctly, which is quite easy to do. So there's a bit of a catch gotcha there to be aware of. But it does mean that we get to use the nice Android X extensions. So this is the view models extension available in Android KTX. You merely inject your global view model factory and then use this as a factory for the extension. Now this is really nice, and it solves a lot of good points. So having a map of providers allows you to inject use the inject annotation on your view model. It allows you to use these Android X extensions. But perhaps a downside is that your view model is going to be existing in your state application-wide graph. Now you might have not have a problem with this, but I prefer to narrow the scope of the factory to the area where it's actually going to be used, so I can have a bit more granular control of the components. This is all theoretical, you don't really need to, but I made a modification to this view model factory, which uses type of the view model to actually ensure that you're only using one provider. So it just basically ensures that the provider injected is the correct type, and then when injected, you use the generic type of the view model in question, and that will actually end up using the correct type from the correct component and the correct subcomponent. So your view model factory is only going to have one provider there, and you use the same mechanism. And you can ensure that it's a one-for-one type consistency. So back to the world's most famous dependency injection example. Because we don't all live in a world of thermosiphons and hooking this up with Android is difficult, we have the world of dagger.android with contributes Android injector. Now, dagger.android offered a really good approach or interesting approach to simplifying the problem injection target needing to know about its constructor. This has been considered for a long time an anti-pattern, and that breaks the core principle of dependency injection in that a class shouldn't know anything about how it's injected. So there was a sacrifice of compilation time safety here to achieve this. And you'll find that out if you forget to bind your activity at runtime, and then you'll get a runtime crash. So this isn't a talk about Dagger Android. Dagger Android has had its day in the sun, and it's now time to move on. So there was the talk from Manuel and Daniel at the Android Developer Summit back last year in the before times about the current state of dependency injection in Android, where they covered the state of dagger.android and what was to be expected in the near future. They also stated that dagger.android will no longer receive any new features, and it will continue to receive bug fixes, but there will be no more feature updates. This actually required the clarification after this that it's not deprecated. It's not just deprecated as of yet, and we will just probably adding new features. That is until, of course, we are presented with Dagger Hilt, A New Hope. Now, it's still in alpha, so we can't maybe not use it in our production capacities, so maybe not yet. But I would definitely encourage you to try it out, maybe in a side project or maybe in somewhere where it's only internal facing. Some parts are hard to follow, but when I started using it or started trying it out, I was actually kind of a little bit confused, only because I was expecting there to be more. And I was setting it up and I was like, is that it? Like, is that all I have to do? I was really confused that all of the complexity and difficulty that I've worked with Dagger over the years and learned that, okay, I need to set up a component, I need to set up modules here and there. And I was expecting this, but Dagger Hilt seems to extremely simplify this. So the idea is that you no longer actually define your own components. The components are sort of predefined for you. And those are, singleton component, service component, activity retain component. Each of the components for your Android manifest entries. Sorry, not manifest entries, because this is including fragment and view. And there's a difference here, of course, between activity retain component and activity component. This is because one is able to use context and one is not. This is to make sure that when the component, which is retained through orientation change, it does not leak context. So because the components are predefined, you don't actually have to define them yourself, and you define your components, your modules to install into those components. So it provides you with these predefined sets of scopes and components that you can use. And each one of these components has access to the binding that occurs at that level. So for a singleton, this would represent an application binding. Activity would be activity context, fragment, view. You get the idea. So this means that we only have to mark our entry points. So in this case, we're marking the Android app as an entry point, and then we can start using the injections after the onCreate. This is achieved through use of the Dagger Hilt plugin. So it actually rewrites this little bit of code here. This is what you'd have to do if you weren't using the plugin. You'd have to extend from a generated class and then use the superclass in an annotation. So it rewrites your bytecode from this to be something a bit more pleasant, as we saw in the previous example here. So the dependencies to use that, that's built in with the plugin, but if you want to use the highly elusive view model inject, this isn't actually part of the Hilt library. So you have to use this from the Android X team. This has been built in tandem with Hilt to use it with view models. And I fully expect there to be more implementation in due time. And it will look a little bit like this. So it uses an approach similar to the assisted injection, as I mentioned earlier, with view injection, where you're marking some parameters as injected, as assisted, sorry. And these will be injected into the factory at runtime when they are available, and the normal injections will be provided into the graph as they're needed. Here we're using game listing. And this will be all you need to actually use this, and you can go ahead and use the traditional view models extension delegate available from Android X on your activity or fragment without having to provide the factory, because the view model provider using the receiving class of the activity or the fragment will actually have that information already from the injection graph. So it's all handed to you. It's simple as that. You don't have to bother about having this view model factory providers. And this is quite a nice feature. But like I said, still alpha. There's also an honorable mention, Project Anvil from Square, formerly known as Project Hephaestus, the god of fire and metalworking, but was renamed because apparently Project Hephaestus is hard to say. So this is now named Project Anvil, and it much does the same job as the install-in on modules, allowing you to sort of install modules into components rather than having components specifying modules. So it's much more kind of modular, granular control. If you're already using Hilt, you probably don't need to use Anvil. However, there are numerous performance benefits to consider if you want to use Anvil, as they've done a lot of performance metrics measurements on this project website. You can go and see. Cool. So nearing the end, some further reading I can recommend. The video from Manuel and David at Android Summit last year. Jake Wharton, Helping Dagger Help You, where he goes into some details about how to use the assisted annotation, especially when using this for layout inflation. Dagger Kotlin Best Practices. This is the thread I mentioned earlier on GitHub. Dagger 2 Official Guidelines from Threads. I recommend this approach. It's inspired from a lot of the comments in the GitHub thread and from Kotlin code style best practices as well. And from Zach, some Dagger party tricks, which are really quite useful, and some things in there that I had no idea about before reading them and are quite interesting. So I highly recommend checking those out. As mentioned earlier, I will share the slides as well. You can find them on my Twitter, and I'm sure we'll share them through the Droidcon channels as well. So that makes everything. Thank you very much.
Thank you. Thank you very much. Thank you very much, Ash, for this wonderful webinar. And I'd like to thank again our sponsor, Bluetooth. And now I can leave you to the question and answers. We can check if there is any question. Please post your question on YouTube comments. And thank you again, Ash. I will leave you to the question.
Thanks. So maybe I should open questions.
I cannot see any question right now. Maybe we can wait for 1 or 2 minutes.
Are the questions only on YouTube, or are they coming up in StreamYard as well?
They're on YouTube, but you can check them on the comment bar.
I see. Maybe it's too early in the morning.
I think that there is no questions. So I'd like to thank you again, and see you all on Droidcon live on the 27th and 28th of November. Thank you again, Ash, and thank to the sponsor, Bluetooth.
Thanks for having me.
Bye-bye, Ash.
See you.